we are going to look at even and odd functions. So to start with, when you have an even function, you are looking for symmetry around your y-axis. And so, in other words, if you took a graph and you folded it on the y-axis, like this one down here, you would have two mirror images. So notice in this case that I don't have two mirror images. If I were to fold it, while these points reflect each other here, the difference is these right here do not. So I would say that's not y-axis symmetry. Whereas if you're looking at odd functions, you're going to be looking for symmetry around the origin. And actually it's going to be easier if you look at some points on the graph in that case. And so when you're looking for symmetry with respect to your origin, if you have a point on your graph and then you take the negative of each of those values, if that point is also on the graph, that's when you have symmetry around your origin. And so again, if I look at this example down here, for example, if I take the point 3, 3, then based on this definition, -3 should also be on the graph, which that's not. It would have to be down over here in order to have symmetry around the origin. Now, with your y-axis symmetry, you can also look at ordered pairs. So for every point on your graph, if you have a negative x with the same y value, then you would have what we call symmetry around that y-axis. And so again, when I go back and I look at this particular graph, here's a point on my graph, and because the negative x is with the y, those two would have the symmetry, but remember down here we didn't have the same thing, so the whole graph is not considered even in that particular case. So that's the main definitions. Now we have to apply it both graphically and with equations. So again, when I look at this first particular example, and they are asking me to use the given graph and determine whether it is even, odd, or neither. So once again, on the even, I'm looking if there is y-axis symmetry. So if I were to fold on this blue line, are the points mirror images? And we said this was the issue where they weren't. So we say it is not even. For odd, look specifically at the points and make sure for every ordered pair that you also have the negative of those values. And in that case, we do not. And so overall, I would have to determine that this particular graph is neither even nor odd. Now, when you're doing it with an equation as opposed to an actual graph, then what you want to do instead is you want to evaluate your function at a negative x value, and then we're going to see what happens. So this particular function, they give me x cubed plus 7 times x. So again, I like to write that function down first with parentheses in place of the x, and then go back and everywhere you had parentheses, go ahead and plug in negative x. Now you're going to simplify. So when I cube a negative, think of that like a -1, it's still negative. And then when I cube the x, it becomes x cubed. And then over here, when I multiply 7 times negative x, I get negative 7x. Now, what you want to do is you want to compare this answer to the original function. And if they are totally opposite of each other, so in other words, if your f evaluated at negative x has all opposite signs, where we say it's the negative of f of x, then as you can see up here with this definition, in that case it would be an odd function. So we consider this to be an odd function. Notice here we had positive x cubed plus 7x. Here we have negative x cubed minus 7x. So that's what makes that odd. When we look at the next one, again, when you're trying to decide whether odd or even, you always plug in or you evaluate the f of negative x. So this particular function, the equation is a 2 times an x squared plus an x to the 4th power. So again, write that down first with parentheses in place of your x, and then go back and everywhere you've got those parentheses, plug in negative x. And then we simplify. Now what happens here, when you square that negative one factor, it becomes positive. Of course, when you square the x, it becomes x squared, so this term becomes a 2x squared. When you raise a factor of negative 1 to an even power, it becomes positive as well, and then of course, x raised to the power of fourth would be x to the fourth. And so what you will notice in this case is that we ended up with the same exact equation that we started with. And so what we say in this case is when you plug in and evaluate your f of negative x, if it's equal to the same thing that you started with, which is what we got in this case, and notice it's up here in this definition, that is how you know that you have an actual even function.